Okay, good morning. I'm gonna explain one of the questions I've taken from this book. Okay, if you can see this book, it's Ace Ahead STPM Text, right? Okay, chapter 12, checkpoint 12.1, question number 8. Okay, if you have trouble with this question, okay, I'm going to explain it a little bit more so that you can understand if it works. Now, question gives you y, which is x cubed. Okay, y is x cubed divided by x squared minus y is x cubed divided by x squared minus 1. They ask you to find the stationary points and determine its nature. Now, if you want to determine, they ask you to determine stationary point. They ask you to determine stationary point and also determine its nature. Of course, you have to do your dy dx, and next you have to do your d to y dx too. Okay, dy dx using quotient rule, right? Quotient rule, everybody remembers from Form 4. Okay, v du dx minus u dv dx divided by v squared. Okay, numerator is u, denominator is v. Okay, go through the calculations, set it to be 0. Notice here, right, dy dx equals to 0, right, and here 0, I get rid of the denominator, right? Because you're setting it to 0, right, the denominator becomes useless. I don't need to write the denominator already. When the numerator is 0, whatever the denominator is, doesn't matter anymore. Okay, so 0 is equal to this product. Okay, of course, you can, if it's 0, then x has to be 0. Okay, x 0, y also 0. Okay. You get y equals to 0 when you set the value of 0 of x here. Okay, so y 0, x 0, you get 1 point. Okay, that's your stationary point, the first stationary point. Then you go on, right? You go on to find out what is the rest of the stationary points. Okay. So when this is 0, okay, so this is, now you want this to be 0, right? You want this to be 0, right? Then you simplify your equation. Okay, your expression being simplified here. You have two answers. X equals to cube root, square root of 3 and negative square root of 3. Okay, set 3 and negative set 3. Alright. Yeah, of course you need y for that. Here, I do it here. When x equals to square root of 3, your y is 3 times square root of 3 divided by 2. When x is negative square root of 3, your y is negative 3 square root of 3 divided by 2. Okay, so that's your two other points. Okay, in terms of determining the nature, okay, determining the nature, I'm going to need to do the second derivative, d2y dx2. In order to differentiate dy dx, I need my complete dy dx, right? Okay, so I'm going to take my dy dx from here to here, right? Simplify it, then differentiate it. Okay, you get a nasty, complicated expression there, but it's okay. We're not going to simplify it. We're just going to substitute the values of x, right? So I'm going to substitute the value of x equals to 0 here. Okay, so d2y dx2. d2y dx2, when x equals to 0, the value is 0. Right? So when the value of 0, you can make a conclusion. Okay, what's your conclusion? 0, 0 is your point of inflection. Right? Okay, next, take out that nasty expression. Right? Substitute x equals to square root of 3 there. Right? Substitute correctly. Okay, it doesn't matter what the value is. Okay, you just punch in your calculator, see if it's positive or negative, right? The value doesn't matter, you just want to see the sign. So here, it's positive. Okay, the value is positive, therefore your conclusion is minimum point. Okay, when it's negative, Your conclusion? The point is the maximum point. So you have 3 points here. Determine nature of the 3 stationary points. Right. So this is the calculation where I get the coordinates of y. Right. And then they ask you to, what's the next task? After you determine their nature, they ask you to sketch the curve. Okay, I'm referring to the question now. They ask you to sketch the curve and determine the number of real roots of the equation when x cubed equals to k times x squared minus 1, where k is real number, so k is constant, and when k varies. K is a constant with a variable constant. Sorry, a constant when it varies. Right. So in order to sketch the graph, right, it's not that easy to sketch the graph. You need to find out the asymptote, right? So because we're dealing with rational function, we need to find asymptote. Now remember, asymptote is where either x or y goes to infinity. Okay? So first we check as x goes to infinity. What happens when x goes to infinity? Okay? When x goes to infinity, x squared minus 1 is just x squared, right? The constant doesn't make any difference there. As x goes to infinity, x squared minus 1 goes to x squared. So y, okay, y will just go to x cubed. Okay, I missed that. Okay, this is x cubed over x squared. So now y becomes x cubed divided by x squared, which is just x. So as x goes to infinity, y goes to x. Therefore, y equals to x is an asymptote. Right? Okay, now we look for the condition when y goes to infinity. Okay? When does y goes to infinity? If the denominator goes to 0, right? So when x becomes negative 1 or 1. Okay? As x goes to either negative 1 or 1, x squared minus 1 will go to 0. The denominator goes to 0, the function goes to infinity. Y goes to infinity. Okay? So that means x equals to minus 1 and x equals to 1 are asymptotes, vertical asymptotes. Okay. So before you draw the graph, you draw the asymptotes. Okay, y equals to x. Okay, is an asymptote. Here, I forgot to label it. X equals to minus 1 and x equals to 1. Okay, those are the two asymptotes. And using what we know about the stationary points, okay, we have one inflection point at 0. We have, what else? We have a maximum point. Okay, where I label as A. So A here, sorry, that's minimum point. Minimum point is A here, and maximum point here, B. Okay, and there are the values you can figure out using the behavior of the graph. Alright, so there, you have the graph. That's the second task completed. Of course, you need to put in, label the axis. This is y-axis and x-axis. Make sure don't forget that. Okay, you might lose some marks if you forget to label the axis. Right. So next task, the third task, when k varies. Okay, they give you, the question given is x cubed. X cubed is equal to kx squared minus 1 as k varies. Okay, as k varies, how many roots will you have? Okay, you can easily change it back, right, to this expression here. So now you have x cubed, x squared minus 1 equals to k, where k is any real number. Okay, any real number, k varies. So if you look at, I'm going to draw it again. I drew it again actually. I drew the graph again so as not to confuse you. Okay, this is the same graph. Okay, you have an point of inflection here, minimum point, maximum point, right, without the asymptotes. Now, if my k is right here, if k is a positive number that has a value greater than the minimum point, greater than minimum point means greater than 3 set 3 over 2. Okay, when k is greater than 3 set 3 over 2, how many roots do you get? 3 roots, right? 3 points. That's the answer. When k is greater than 3 set 3 over 2, you have 3 points. When k is exactly the minimum point, okay, when k is exactly 3 set 3 over 2, you have 2 roots. When k is between the 2 points there, the 2 minimum and maximum point, when k is between set 3 times 3 over 2 and negative set 3 times 3 over 2, then you only have 1 root, right? There's only one intersection. Root is the intersection between k and the graph. Okay, and lastly, what happened? When x is less than negative 3 set 3 over 2, you have how many roots? Ryan, how many roots here? Ryan? You've been helping me with the video. Can you see? 1, 2, 3 intersection points. So there are 3 roots. Alright, I think that's about it. Question number 8, checkpoint 12.1. Okay, chapter of numerical roots. Oh, okay, thank you.